sued. Cancel Mr. Samuelus. My name's on the internet. How dare you? Anyway, all right. So circumference is what the first part deals with, as far as related to what formula we have here. So really good start with my words there. So, but again, remember, not again, but always read. Okay, so we already know what arc measure is. Arc measures in degrees. Not quite the same way I started the other hour, but we've already done that. So this measure of this arc is 120 degrees because they're equal to the central angle, which is what I'm trying to note there. But what's arc length? Maybe I'll color code that. Arc length is actually a concrete um, measure, like in meters, feet, miles, inches, I don't know, whatever it is. This is actually a concrete distance that you actually travel. So imagine I pull this circle out and make this larger. This 120 stays, that 120 stays because that's like a fractional components of how much of the circle you're dealing with. What's a full circle, by the way? 3, 2, 1, go. 360. But when I pull that circle out or make it smaller, the 120 doesn't change, but the amount of miles, feet, or inches that you travel from J to I changes. The larger the circle radius is, the larger that arc length is. So there's a big difference there. So in green, that is the actual distance you walk from J to L. All right. So understand, or I don't know what that is. It kind of looks like an L. So again, it's going to be based off of circumference. Circumference is the full distance around a circle. So the next parts, I told you not to write this part. What is this fractional part of the circle I'm dealing with? Well, it's 93/60ths because a full circle is 360. If I only have 90 degrees for my central angle, then you have 93/60ths or 1/4 of a circumference. Or this is 63/60ths, and then we reduce. Ooh, then we get tricky. If I wanted to find this arc length, what portion of the circle does this represent? Well, this is 54, so this is 108 degrees. That's last week's stuff. All right, I know that an inscribed angle, the arc it cuts is double. All right, so this is 108 divided by 360. Notice I'm a little raspy. I don't know why. Feel fine, just as weird here. And then this one, excuse me, this is 90, so this is 180 degrees. Oh, so if I drew this, this would be a diameter then. Now I could draw that and make sure that that is. But anyway, that's a half circle. So that's just the first part. And then I'm not doing, I have a gear question, but it just overdone here as far as the explanation. Fine. We'll write down the circumference formula and then look at these two if you wanted to, but this is kind of grade schoolish. What is circumference? 2 pi r. Can you see that? All right, then just make sure when you have a diameter that you understand the radius is half of that. So 2 pi r, and then we'll talk about how you leave your answer an exact or rounded later. Okay, or circumference is pi times diameter, which still gives you 16 pi, either or. So that's what this is all about. The fractional part, we're just going to go right into it. So, and I'm not, no more deriving. That's what the next thing was, and it's all taken care of. Here is the formula. That is circumference. The area of a sector is what portion of the circle are you dealing with? So I need that fraction in front. It really should say central angle or arc length divided by 360 because central angle equals the arc length in question. I'm sorry, arc measure. I just did it wrong. Arc measure is degrees. Arc length is in feet, inches, mile. So this could be measure of central angle divided by 360 or arc measure divided by 360. I just caught myself. So the fraction of the circle you're dealing with. divided by or times circumference. So actually, I should not have highlighted that and do green. That'll just kill the yellow there. So C is circumference. That's what's on the right. What fraction of that circumference you're dealing with is measure of central angle divided by 360. And that's it. And actually, that's why we're going to move into area after this little couple other examples, because it's really the same thing. It's fraction you're dealing with times area. And then area is pi r squared. Okay, and that will be what ends up happening there. And then I'll exercise the leave an exact form and round because, students have a real hard time with that. I don't know why. The difference between the two. Another, another way of saying in exact form is in terms of pi. That's another way of saying inexact. And I guess I'll highlight those that you need to be aware that this could be worded in two different ways. So find the requested information, leave your answer in exact form, and then round to the nearest hundredth. And it makes me sad how many people are not doing that correct in my class. So I will go ahead and get my calculator. I'm going to get the hand version. Oh, forget it. Give them a chance to write here anyway. I'll go ahead and fumble on the calculator. Hit the wrong thing. That's a Mr. Samuelis mistake. I can't complain about the computer on that one. My head's in the way to close the computer program I accidentally opened. Then there's the, there we go. See the calculator taking an hour to open. How's everyone doing today? Good? That's good. Right, got that out of the way. Small talk. All right, clear. Look at all that trigonometry up there. Might still be from you guys. I'm trying to remember if I've been breaking out the calculator with my other classes. Okay, so notice what it says. Find the length of the arc. Your test Thursday or quiz, let's call it, will have questions that say find the measure. Others will say find the length. And you got to be able to read and disseminate which one I have to do. Okay, very simple, very basic. If this is 45, then this is 45 for a measure. All right, so that makes me worried. This is 45 3/60ths of the circumference. And it does give me the radius is 16 millimeters. So it is a radius. So I get to plug in 16. And then at the end, we'll put millimeters because you're an ant walking on this. Okay. How many millimeters did I walk when I went from B to A or A to B? That's what you're answering. All right. You know what 45 over 360 is? 90 is 1/4. So this is 1/8. And then 2 times 16 is 32. This is how I'm leaving it in terms of pi. This equals, and you're allowed to use the equal sign because the pi symbol is the exact form of that magic number. So this becomes 4 pi millimeters. And then approximately use that symbol. Get used to that. Go to your calculator and hit second. What is that? Second upper caret. Delicious. Right. And then times 4, and then that's 12.57. 12.57 millimeters. All right. There's exact, there's approximate above and below each other. Understand the difference. All righty then. We good? Can I move on? Right? I know you have to write this, and you write what you want. I might have some redundancy in here, like, yeah, I get it, kind of thing. Like this next one, I don't even feel like doing it. It's really just 80 over 360 times 2 pi 10. All right. So we're good on that one. This one, this is good. Which one do I have to? This was bad. I'll tell you a story about number 10. I didn't even notice it last year, actually. I'll tell a quick story and I won't even do it. I like these though, because it incorporates last week. What is this arc measure? What does that arc measure? 75, 150, or half of 75? 3, 2, 1, go. Oh, I didn't hear many people that you weren't ready for that. 3, 2, 1, go. It's 150. Then fine. That means this is 150. it means you have 153/60th of a circle. So you have 153/60th of the circumference. That's really what it is. And then 2 pi 48. All right. I don't know if this one worked out so well. Somebody go grab my calculator. No, never mind. I forgot already. I forgot already. So 150 divided by 360, enter, times 2. What was it? Times 48? Was it 48? Help me, help you. Was it 48? Yes. Well, there you go. That ended up working out perfect. So my calculator got me 40. Remember, I never touched the pi button. So you tack on pi like a variable, even though it's not a variable. Variable means changing. Pi is 3.14, blah, 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 blah. Anyway, centimeters. And then you go back and hit times. You got to hit the times button. And then second, carats. 125.66. Notice the pi disappears because I've actually incorporated it into this. Equals, exact, approximate once you hit the pi button. All right. And I hope you get that quick. I was just dealing with a Math 3 regular student on this exact idea of exact and approximate on Friday, and there was a lot of confusion at it. I love this one. It's not really a big deal, but it becomes those problem solving questions. So I'll sit and wait as you write this one down. Given the radius is 60, okay, I have to read. And I don't like that I did that. So it's 60 what? 60 U's. What's U stand for? Unit. Okay, it's the general term. I want units at the end because you have lengths. You have arc length questions. You have arc measure questions. You have area questions. Arc measure is degrees. Arc length is feet, inches, miles. Arc like area questions are feet, inch, miles squared. So this is why we're not jerks by marking you wrong on incorrect labeling. There's a reason for the labeling and making sure a student has a clue what they actually found. So labeling is going to be a big deal this next um, situation. And I'm just kind of stalling to get everyone caught up on the drawing of the picture, but it also is a good discussion or a good point that I'm making here. All right. So there are things that you have to be responsible for. Notice what it says. Find the length, again, as far as our quiz coming up on Thursday of arc AB. That's this one. Oh, so I need that arc measure. All right. Well, with the information given, the measure of arc AB, and again, giving you symbolism as well. If I actually just had that listed, you would need to know that that's what that means. The measure of the arc, which means it's in degrees. I'm going to put a colon there because I got to create an equation for this. The angle on the outside, which is a secant angle from last week, equals half big arc minus small. And I'm going to just put arc AB's measure as X. That's my unknown, what I need to find. Once I get that measure, then I can actually answer this question. All right. I multiply by 2 and then multiply both sides. That gets that half out of the way. Then I subtract 96 and then divide by a negative. I think we should be able to understand that. So ultimately, it's 96 minus 42, which I don't know why I didn't do that mentally. 54. So if I subtracted 96, I get negative 54, but that's what negative x equals. I already know that, so I just get rid of the negatives. Now, with this being 54 degrees, then that means if I drew the central angle, that central angle is 54 degrees. Either or, this is what I need for my question. You have 54 3/60ths of this circle. So you have 54 3/60ths of the circumference. I was trying to grab my word there out of my brain. All right, and then equals, fine. I'll go to the calculator. 54 divided by 360, enter, times 2 times 60. Is that right? I think it might be a nice number. I'll be darned. 18. I think first hour I didn't even do this. And then me's, units. All right. And then now I take that times pi. I won't do the next one, but I'll tell you a funny story that, oh, first hour loved it. Mr. Samuelis making a mistake just made their day. So I'll tell you that. So just they were just, oh yeah, look at him. I knew it. He doesn't know what he's doing. All right. Last year we didn't even catch it. A student very awesomely said, don't you have to do this in this question? Don't write this down. Look at the units. What is the radius in? Inches. What is the area that they give or the arc length in? Feet. Last year I completely ignored it. We just did it and then basically we just thought it was in inches. Nobody caught it, not even me. Because I looked at my notes from last year. I always have those complete from last year, just kind of look at them again. Here's the problem with this question. This is why in first hour we got a really weird answer for an angle measure. We got like 900 degrees for this arc measure. If this was 27 inches, which is just barely over 2 feet, then this arc length right here is actually 37 point some feet. That is nearly impossible with such a small radius to get an arc length that large. So that's like a nonsensical setup in this question. Does anyone understand what I mean by that? This radius, I mean, I can't have a radius of like 2 inches and then the arc length is 74 miles. How could that even possibly, and that's a really obnoxious extrapolation there. That arc length is too large if it was 12 pi feet. So in first hour, when I actually set up this question, we got like a 900 something degree angle there. That's why that happened. So this is really supposed to say inches. So I'm just kind of covering myself why that happened last year and why we didn't even catch it last year because no one noticed the feet inches thing, not even me. So anyway, you don't care about that story. In case someone in the first hour watches this video, I'm covering my bases there. Okay, so this is very similar. Give the length of arc B. Given the length of arc AB, what is the length of the radius? So this is what I'm finding. Feel free to call that X. So very similar to the last one, except the last one we were finding the missing angle measure in the middle. All you do is do your formula. Arc length. I don't even know what that variable would be. I know arc measure is um, well, never mind. Blabbering. Equals uh, angle divided by 360, or central angle, I should say. Oh, times 2 pi r. Why did I call that x? Why don't I just call it r? That was a silly decision. And that's what I'm trying to find. Oh, and they give me the arc length. So let's be a little bit practical and put 24 pi here. So the arc length is given. All this is a question where you find the unknown. So you put in the parts that are given. In this case, they give you the arc length, and then go ahead and find the unknown through solving. Here's what I do on these kind of questions. Be careful. But they do give this in terms of pi. So I'm going to go ahead and divide both sides by pi. Is that reasonable? Allowed to do that? Everyone okay? Next thing I'm probably going to do is also divide by 2. Because what's 24 divided by 2? 12. Okay, fine. I'll put the pi in here as well. And now these are gone and these are gone. And then I'll handle the fractional part. And then now I know on my calculator. By the way, 120 over 360 is 1/3. Wow. Then I guess I can do this real fast. Go ahead and multiply by 3 both sides. And then R equals 36 millimeters. All right. And that's how you end up solving that. So 120, 240, 360. Just wanted to make sure I'm okay. There's that first bell. You need to be finishing up that test, by the way. We're actually over the limit on the time on that. That was a short one. It always happens when I have someone making up a test. I forget the time factor. Okay, and then I got 2 more of these. Oh, oh, there it is. Okay. 2 more of these. This is not that bad. I got to check a question on tomorrow. Tomorrow, we're actually done. This is it. No more new stuff. That's why we're having our quiz Thursday. 3 quick hits on note things. Then Friday maybe gave you a little bit of a headache on that circle challenge thing. Love those questions. All right, find a perimeter of the composite figure. Remember, perimeter is walking around the outer edge. So then walking around to this. So I don't need that dotted line. You're walking around the outer edge of this. Dotted line is not considered in this. That's why I noticed tomorrow there's a goofy question. I want to see how I have to change it, what I want to do about it. All right. Um, okay. So obviously this has to be 15. We can assume that we have a rectangle there. What I don't need is that 30. All right. But I do need this 30 to come up with the ready one radius. And that happens to be luckily another 15. Now, what do I have for the circle? What fraction of that circle do I have? 3, 2, 1, go. Half. So it's 30 plus 15 plus 15 plus half of the circumference. 2 pi times 15. I don't need no central angle for this. I understand and I see that I have half a circle, but I see that I have that there. So I do have the 180. So I guess that did tell me that. I guess I assumed too much that that was the diameter, but it has to be. When you attach a circle like this, attached to an end of a rectangle, that has to be half of a circle. That has to be the diameter. No two ways about it. All right. So that's actually 60. And then be careful. These cannot be combined for exact. You don't make that 75 pi. Pi is like a variable. So that is the exact answer, and that is in terms of centimeters. Then you can flat out go to your calculator, 60 plus, what did it end up being, 15 pi? My memory's going, man. Thanks. Enter. And then you get 107.12. 107.12 if I follow um, the thing up there, what they ask you to do. Okay, so perimeter, and then next thing we'll do area of composite. Or yeah, actually tomorrow I do a lot of area of composite figures. Then we have another area chapter of all like figures and geometry. Not all necessarily, but getting into polygons, and then circles are going to come back. So we have to recall these perimeters and area things that I'm going to do today. All right, perimeter of the shaded region. Again, perimeter it says. So I'm walking, I walk this edge, then I walk this edge, then I walk this edge, and then I walk this edge, and I'm back to where I started. So it is that how long or how far did I walk? Of course, you can see I have 20 plus 20, the two outer edges of the rectangle that I hit. And how much of a circle have I walked circumference wise? 3, 2, 1. Pick a word. Go. Not half. Whole. Half plus half equals whole. I have half up there and half down there. All right. So anyway, this is 8 yards. So this is 4 and 4. All right. So when I have a diameter, get the radius. And it's actually just circumference. 2 pi r, because it is a full circle. The bottom half and the top half together is a full, so it's full circumference. So this is 40 plus 8 pi, and then you can type it on your calculator. I'm not boring you with. Go to the calculator. All right, now let's move on to area. Boom shakalaka. Okay, and then we're just going right to it. No extrapolation. Here is your area formula. That is pi r squared. And then this is the fraction of the circle. I'm just putting the word fraction here. This should be completely and totally understandable. The only thing I'll add one more time is measure of central angle, or arc measure divided by 360. Arc measure of the arc in question that denotes the portion of the sector you're dealing with. It's one or the other. Okay. Sorry, didn't hit that yellow there. Okay. Just a little bit of a breakdown there, but it's really the final end that we need. This is why we're doing these together, because these are based off of grade school formulas. What time is it? Boy, staring at that clock. That makes it go faster. Wrong. Why are you shaking your head, Anthony? In disgust? All right, sorry. That's why I'm here. To disgust students. There. Okay, can I move on? All right. I'll take that lack of a response as a yes. Mickey Mouse, and then we'll move on and get more challenging. I think it's the same questions. I think I took some of the same drawings, but now just changed it. Find the area of the sector of APB, given that the radius is 24 millimeters. I don't know if that's the same as one we dealt with before, but I don't know. All right. So we got it. It's 45 3/60ths. So it's this area that I'm finding, this shaded, I literally hit that shaded region. So what is that space inside? All right. So it's 45 3/60ths again, but now it's pi r squared. I don't know what 24 squared is. 25 squared, 625. I bet you 24 squared is 576. Let's check Mr. Samuelis's boom shakalaka. All right. And then times 45, enter, divided by, so proud of myself. And then divided by 360, enter. Ooh, okay. 72. Notice I never touched the pi button. Sorry if I didn't put directions, but we're going to keep going with the directions. Exact, or in terms of pi, and then to the nearest hundredth. All right. Sometimes I like the tenth. Today we're doing the hundredth. And then that is times pi. See, is anyone checking with their calculator out there? Anyone? Am I getting the same answers? This is another reason. I ain't perfect. I'm far from it. Believe me. I make mistakes, man. I make mistakes all the time. 226.19, 226.19. All right. And then it's millimeters squared. We'll do another area thing later. It's actually coming up because we're in our geometry parts. Well, coming up. It's after spring break. But I think that's what we get into right after spring break. We talk about four-sided figures, then polygons, and then we get into area of those things. Then I have a whole area set of slides and why it's millimeters squared. But really what it means is 226 one by one millimeter blocks fit inside that area, right? Fit inside that space. That's why it's millimeters squared. 226 of these, if these were 1 by 1 millimeter. All right, I can't draw it that small. It would be a lot smaller than that. But that's why you do millimeter squared if you ever wondered about that. Again, I think I think this is the same drawing, isn't it? But now I asked for area of the sector. So again, incorporating what we had before, this is 150 degrees because it's double that. So it's 150 3/60ths of the area, which is pi 48 squared. And let's spare you the calculator thing. You should know how to do the calculator at this point. I'm done. Okay. And then leave it in terms of pi. Already talked about that. Let's go ahead and do this one though, and we'll do it all the way. Given that the area is 120, or 7, or sorry, I looked at this, 27 pi inches squared. Now be careful. Doesn't always have to be in terms of pi. It could have said 27 inches squared. You got to be careful. That's way different than 27 pi. Pi is 3.14, so it's more than triple 27. All right, so be careful when pi is in the answer or not. This one says 27 pi inches squared. What is the diameter? Careful. What does R stand for? Radius. So area of a sector equals angle over 360 times pi r squared. And basically you fill in what you know. Well, I know what the angle is. That's 120 3/60ths. That's the whole point. I want to find the diameter, so I have to find r. So that is remaining the unknown. Oh, I have 27 pi as the area, so I can plug it in. We were a little lazy on the units, but this is maybe not. This is honors, so let's actually not be lazy. This is um 27 pi inches squared, 27. And then when I divide and when I do square roots, then this is going to be r. And then when I divide by an r or inches in inches, then when I divide inches squared by inches, I end up with inches. A little too much. I'm just going to leave it at that. Actually, I should have put units or inches squared, not r squared. So I already screwed up on that. So never mind anything that I just said there. You know what I'm going to divide by first, though? This pi. I just want to get rid of it. I don't want to see it. And because I have pi in the answer over on the right, that's good. You know what 120 over 360 is? 1/3 r squared. Did I make a mistake first hour again? I feel like I did. All right. So it's pi r squared. I feel like I incorporated a 2 in the question and they didn't say a word. All right. Anyway, I know that happened. Times 3 times 3. Because what's 3 times 27? A number. 24. No, I was right. It is. Okay. We did have 81 in that class. And then what does R equal, pirates? 9. Okay. So what is the diameter then? 18. I don't think I did that. I don't think I did 18 at the end. Maybe that was the mistake that I'm thinking of. Because it asked for the diameter. So be careful. Okay. So again, just fill in the missing parts with the formula that you know. We're almost done. Okay, now the next thing. Can everyone say the word segment? Say it. Segment. 3, 2, 1. Blah. Segment of a circle is a region of the circle bounded by a chord and the included arc. So that is the area of a segment. Just that part. Let's come up with a way to solve this. First of all, what is this a picture of? Three, just the yellow. 3, 2, 1, go. No, what is this a picture of? It's just one answer. It's a triangle. Okay. Next, what is the green a picture of? Starts with an S. 3, 2, 1, go. Sa. So it's everything we've been doing right now. Everyone say it. 3, 2, 1, go. Sector. So how do you think I'm gonna find the area of the segments? I'm gonna do. Everyone say it. Sector. Can you see this? Then what? Minus what? Triangle. That's how you're going to get the area of the segment. It's actually very easy. Now, when we come back from break and we have more area questions, when we incorporate quadrilaterals and polygons, I have a whole slew of area of shaded region questions. Love it. I actually stole them off the internet. But I can recognize a good worksheet when I see it on the internet and then grab it. All right. So those are going to come big time here. I'm just going to go. I'm just going to go to drawings. You have to be able to read questions and make drawings from it. I'm just going to go to drawings here. So find the area of the shaded region. Wrong. Find the area of the segments. Let's let's uh let's really exercise a vocab word. It's kind of a weird word to call that a segment because a segment's just a and I want to say line, but it's not a line. Just has endpoints. But for a circle, that area is called a segment. It's kind of wild. What's wrong, Anthony? Boy, I'm really irritating you today. Sorry, just trying to grab my words to see him over here. By the way, you're on the video twice. Yay. Okay, so I just said it's sector minus triangle. Now, luckily, that's 90 degrees there. So for the triangle, I have an easy area formula, half base times height. And when it's a 90-degree angle, I have the base and the height because it stands straight up and down. So real lucky here. So sector is 90 divided by 360. Two wrong. Pi r squared. I almost went into arc length formula. I got screwed up there. So pi times 16 squared, and then minus half 16 16. Because it's a right triangle, 16 is the base, 16 is also the height to stand straight up and down. Lucky. Okay, 16 squared, I believe that's 256. 1/4 of that. Ooh, 16. So it take a 440, say 64. I think 1/4 of 256 is 64 pi. Just type it on your calculator if you want. Wait a minute. Half of 256. Oh, close. 128. Does that sound about right? All right, that's the exact. Then this one I'll go to the calculator. So I'm going to do equals. And then yet again, you do not take 64 minus 128. Pi is like a variable. So when you leave this in exact form, that is it. You can do nothing more. Approximate means you touch the calculator button and calculate and get the decimal. I know that was like a redundant statement there. Hopefully I don't annoy anyone anymore. Minus 128. Enter 73.06. 73.06. Oh, and then I don't know if I did this. Let me check my notes up above there. Let's check my the ones that I did that I put labels. Otherwise, you're what, Mr. Samuelus? Gone. All right, I didn't finish 3, so that's okay. I am gonna do this one, and then maybe let's see. Oh yeah, maybe a couple more. What time do we have here? Ooh, wow, we went pretty far. Yep, get that stretching in. A lot of people stretching during the notes. Don't want to pull a back muscle during the notes here. Okay, now 60 degrees. Yeah, there you go. Nice. Group in the back. Whew. Okay, so that's 60 degrees right there. All right. So remember, find the area of the segment, sector minus triangle. So I'll write it one more time. Sector minus triangle. Okay. Got some tough things going on here, though. And then hopefully you remember this formula. This is why we gave this to you, so that this stuff can kind of happen. All right, sector is pretty easy. It's 63/60ths. And then what does it say? XZ. So I made a mistake the other hour. I thought XY was 18, which would have been a little bit better question. But by the way, we do have something here. If this angle is 60 degrees and then these two radii are equal, I at least have an isosceles triangle where I have 120 left for these two. But if I have 120 left for these two, aren't these also 60? They have to be. So guess what? These are all 18. All the sides of that triangle are 18. That just blew my mind. We have another way we could find the area of that triangle because I gave you 2 formulas in our last chapter. 2. All right. So sector, let's finish this off. That is 18 squared pi. And then the area of the triangle. Remember this formula for area. I have side angle side. I had a formula from last chapter that it was, anyone remember? Half 18 times 18. Does anyone remember? Times what trig function? Sine. Sine of who? There's really only one angle measure. 60. That is literally our area formula from last chapter. See? Bringing stuff back from that. Or we could take this 60-degree triangle out. Here's Z up here. Here's X. Here's Y. If you don't like that, that's unfair, Mr. S. No, it isn't. Old stuff. And then I'm going to drop a Al. Anyone? Al? Anyone? Al to anyone? altitude. And then what does that make 60 degrees? What happens to 60 when I drop that altitude? It gets divided in half, and therefore this is 60. And if this is 18, what is this side? What is the side opposite 30 degrees? Nuh. Well, we should know that 18 gets cut in half. So 9. And then what is this altitude now? 9, 9 roots. Anyone? 3, and then 18. So this altitude is actually 9 root 3. So it could be 60. Sorry, that 6 got a little weird. 3/60ths. That's me. 18 squared pi minus half base, which is 18, times height, which is 9 root 3. True that. All right. And that's exactly what happened. By the way, sine of 60 is root 3 over 2. Root 3 2 times 18. Root 3 over 2 times 18 would be 9 root 3 anyway. All right. And then I'm not going to cover the third one. I gave you a formula for when you have three sides of a triangle. That was the s times s minus a times s minus b times s minus c square roots. All right. And S is semi-perimeter. All right. So just the idea is there. Drink time. We already had drink time, sir. That's illegal. All right. Oh, no, look at that. Go ahead. Stop me. Then he takes another drink right after that. I love it. Kids these days love it. You can't tell me that. I have rights. Anyway, I'm going to skip to this one and then we'll finish it after that incident. Okay, what is this question's area? Okay, so what are we going to do for this this picture, this thing? We're going to find the whole area minus, what's our word for the day? Segment. But it actually is a little weird. And I really can't think of any other way. I feel like there's maybe a quicker way to think about this because segment is kind of weird. And this is what we have to do when we have multi-shaded regions. Like what's my ultimate thing I have to do? Right? And luckily I got a right triangle again. So AO, that's the radius. So whole area is just pi r squared. And then minus segment, I need this in brackets because segment is sector minus triangle, which kind of stinks. So the sector is 90/3/60ths of our area minus triangle, which is half 20 times 20. Good times. I think I can actually get this one. 20 squared is 400 minus, keep this in brackets for a second. 1/4 of 400, right? 93/60ths is 1 hundo. So that's easy. And then 20 times 400, half of that is 2 hundo, right? Now, all I have to do is distribute 40 pi minus 400 pi minus 100 pi plus 200. This is 300 pi plus 200. Cannot add those together. Millimeters squared. All right. And then that be it. And this is the last lesson before your quiz Thursday, this only being a Monday. All right. Now you can get your water. Water. Sahara Desert.